Welcome to section 6.3. In 6.3, we're looking at making connection between fractions and decimals and making that connection stronger. So some of the work that you did in the chapter 5 area can help here. But in general, we just want to make sure that there is a good connection between fractions and decimals for you because we use them so much in our world. And so as we look at some of the homework problems, one of the homework problems asks about this. They ask about the expression 7/4, and they want to know what 7/4 is equivalent to, and they give us some options. Option A, is it equivalent to 1.7? And I don't know if you know this line. That line means that the 7 repeats over and over. So this means it's 1.7777, and that 7 just continues to go. We'll use that a little bit later on. B, 70 over 40. C, 1.750 with a line over the 0, which means this is 1.75 and then a bunch of zeros. And then D, shouldn't say and then D, there's one more, 4/7. And then E, 1.75. And so how are we going to know? Well, let's take a look on our calculator. They're not asking us to do this by hand. If we look at 7/4, realize what that is. To change a fraction into a decimal, realize that the fraction is just a division symbol. So we just need to take 7 and divide it by 4 if you did not know that already. They're thinking that you did. And so what do I get on my calculator? I get 1.75. So what are some equivalent things? Well, let's X out the things that are not equivalent. Well, A is not equivalent. It's not 1.7 repeating. How about this fraction 70 over 40? Is that a good answer for us? And the answer is yes. 70 over 40 would reduce to 7/4, so it is the same thing. If you questioned it, just check out what 70 divided by 40 is. If you look at 70 divided by 40, you're going to get the same 1.75. Now what about this C one? 1.75 with the 0 with the line over that 0, that's equivalent. You can tack on as many zeros as you want. The flip of it, 4/7 is not equivalent, and so that guy's out. But 1.75 is exactly what my calculator displayed. And so on these questions, you're going to select all that are going to work and be equivalent to that. So the goal is to get you a connection between fractions and decimals. So with fractions, if we divide the numerator by the denominator, or the top number by the bottom number, we'll get the decimal representation. And so that's how your homework starts out, is with that type of question. And then what it gets into is some fraction work. They want to make sure that you remember how to add and subtract fractions, and how to multiply and divide. And so you'll see questions like this: 1/9 plus 5/6. And you'll see questions like, let me get a multiplication one in here, -7/9 times -7/12. Now, which one's easier? It's actually the multiplication and division that is easier, because as we saw above, fractions are just division, so we're in the same family. So here we do what we thought we could do. 7 times 7, well, actually, let me say negative times negative is a positive. So if we accounted for that, 7 times 7 is 49. 9 times 12, well, if we didn't know it, we could use the calculator, but it should be 108. Okay, we get a nice 108 out of that. Now, there was no cancellation that could happen there, because there was nothing alike on the top and the bottom, but you may have remembered cross-canceling or something like that, and maybe we'll see that in the future. Addition and subtraction is a little bit harder, because you're mixing operations of division with addition. Okay, let me highlight where the division is. Here's the division, and it's being mixed with this addition. which is causing us not to be able to combine those very easily. What we need to get them is into equal segments. So remember our work in Chapter 5. Let's get common denominators. The common denominator between 6 and 9. Well, we can do that through the least common multiple, or we could just range through the multiples of 9, and we'll realize really quickly it's 18. So what needs to change? Well, my top number and bottom number here need to be multiplied by 2. And on the other fraction, they need to be multiplied by 3. And so we're going to get 2 times 1 or 2 up there, and 3 times 5, 15. Now remember, we did that so that we could put them together. So now let's put them together. And we do, and get 17 18ths really nicely. So as we move forward in there, there's lots of practice with this. There's 26 total questions in there. And that seems to be a good mix of not overwhelming you through that. Let's make sure you remember how to divide. Here I'm looking at a problem in the homework, 5/12 divided by 4/3. And the reason why I wanted to look at the homework was for us to get an idea of the complexity there. So when you have a division, maybe you remember this from your earlier days, I think you will, we change our divisions into multiplications. And we have 5/12, and two things change. I'll put them in red. The division becomes a multiplication, and the 4/3 becomes 3/4. So nothing happens to that first number. We're just multiplying by what we call the reciprocal, or the flip of the second. And then we look to see if there's any cancellation we can do. Certainly I could do the straight product and say 5 times 3 is 15, and 12 times 4 is 48. If I left it like that, I would not have the right answer, because a 3 goes into both of these, and I might not have seen that. But if I take 15 and divide it by 3, I get 5. 48 divided by 3 is 16, so it's the 5/16 that they're going to have as the right answer. If you put 15 over 48, it will not be recognized as the right answer. How can we have seen that a little bit better back here? We could have looked for commonalities. So for example, is there anything that 5 will go into that 12 will? No. 5 will go into that 4 will? No. 3 will go into that 12 will? Yes. 3 divided by 3 is 1. 12 divided by 3 is 4. So you can pull that 3 out if you remember that from your arithmetic days. 5 times 1 is 5. 4 times 4 is 16. So this should go pretty quickly. And so we would get right to this answer right there. Now I did pick some where you had some order of operations involved. But before I get to that, I want to make sure you remember mixed numeral addition and subtraction. So here's a problem where we have 4 3/4 plus 3 1/6. And so what we need to do is just add their fraction parts and add their whole number parts. So if I line them up, my set recommendation would be to put them right over one another. If we're going to add the fraction parts, those fractions are going to have to change. They're both going to have the same denominator, and the first time they hook up with is 12. 6 times 2 is 12, and 2 times 1 is 2. 4 times 3 is 12, and 3 times 3 is 9. And so now we just add, right? We've replaced these fractions. 9/12 and 2/12 is 11/12. 4 plus 3 is the nice number 7. So we get a nice 7 and 11/12 out of that. If I had something like 6 2/3 minus 4 1/6, same thing. I need to get new fractions that have common denominators. So this is 4/6. And this would stay as 1/6. So if I subtract those fractions, I get 3/6, and if I subtract the numbers, I get 2. Now remember, I can't leave anything unreduced, so they won't recognize this as the right answer, because a 3/6 will reduce to 1/2. And so they have that mixed numeral work in there. Now, what if we had something like this? -10.5 times 1 3/5. Here the best thing to do would be to put them in their improper fraction form. So I don't know if you remember how to do that, but you take the 10 times the 2 and add 1. So 10 times 2 is 20 plus 1 is 21 halves. 1 times 5 is 5 plus 3 is 8 fifths. So they're assuming that we remember how to convert a fraction from improper to mixed numeral form, and from mixed numeral like we're doing here to improper. So again, I took the 10 times the 2 for 20 and then added the 1, so it's a times here. And so now we have this, negative 21 halves times 8 fifths. We look for anything that can cancel, and I'm seeing something. A 2 and an 8 should be reduced to a 1 and a 4. So what do we have? We have a negative times a positive, so we're going to get a negative. 84 up top and 5 on the bottom. Now if it starts as mixed numeral, it's got to end as mixed numeral. So what do we do to figure out that? I take 5 into 84. I actually do the division. Goes into 8 once. Goes into 34 6 times. And we get negative 16 and 4 fifths, right? There's nothing else to go into, so we take our remainder over what we were dividing by. So some good reminders in there. And there's lots of fraction work that's involved in courses of study, so we really want you to be proficient with that. So that's just reminding you how to do those. So hopefully you wouldn't be too overwhelmed if you saw something like this. 6 times 1 3/8 plus 2 times 3 1/2 minus 5/8. Hopefully you remember your order of operations, that we need to do multiplication first. So if I'm going to multiply these items, there's two multiplications that take precedence. Let me highlight them for a minute. We have to do this multiplication and this multiplication before we do any addition and subtraction. So as we go to do that, I'm going to need to take that 1 3/8 and rewrite it as an improper fraction. 1 times 8 is 8, plus 3 is 11, plus 2, 3 times 2 is 2, plus, 3 times 2 is 6, plus 1 is 7. Right? So we still have to do this. So remember, I can rewrite these as over 1s. How about between 6 and 8? A 2 can be pulled out for a 3 and a 4. And here I have 33 over 4. What about here? My 2's can cancel out, and I'm just left with 7 minus 5/8. I don't know what you would do next. Maybe you could get everybody over 8 and put everybody together. You could hold off and just get the two fractions together first and see what you got. Let me get everybody over 8. So I know I can change this 4 to an 8 by multiplying top and bottom by 2. So I have 66 over 8. Now what's 7? 8 times 7 is 56, so that's 56 over 8. And then this one is already an 8. So now I could look at this guy and say, oh, I got 66 plus 56 minus 5, or 66 plus 51. You're welcome to use a calculator in all this, right, if you start to doubt yourself. And it looks like we get a nice 117 over 8. So then on your calculator, you can hit divide by 8. And it will tell you that it's 14 and a decimal. But at least you know it goes in 14 times. So then you can see what 8 times 14 is. And you realize that's 112. And so we were off by 5/8. So again, I could have done a long division thing or used my calculator. Long division, 8, 9, 10, 11. 8 times 4 is 32, and we'd be off by 5. Okay, so we have 14 and 5/8 as the right answer there. So there is some order of operation problems. Another thing they're going to ask about is when a decimal terminates or repeats. And so they're going to ask something about 5/8. And everything depends upon how it breaks down. So if you remember our prime factorization, 8, we realize, is just a bunch of 2's. If you divide by 2, it's going to terminate. Things that cause us to repeat, division by 2, division by 5, but if you have a 3 involved, or any multiple of 3, it usually will go on for, not usually, it always goes on forever. So because the 8 on the bottom involves only 2's, it's going to terminate. Let's compare that with something like 26 over 65. Well, let's take a look at 26 over 65. That's 5 and a 13. It's going to terminate in this because of the 5 and the 13. Really, it's the 3's that create a problem. 5/16 is the next one. Let's see what 16 looks like. Oh, it's just a bunch of 2's. It's going to terminate. So how about something like 1/9, though, the next one that I see? The 9 involves a 3. It's going to repeat and go on forever. Okay. So those are the types of ones they want you to get a quick feel for what's going to happen. So let's look at something like 1/7. Let's look at 1 divided by 7 and see what happens. On my calculator, I'm getting 0.142857 and then a 142,857. It's repeating. So we just found out that a 7 repeats as well. That's the best way to see if something is repeating. If we looked at 1 divided by 13, it should terminate in there, and it does, going through. So 1/7 goes on forever. Okay, so they're going to choose the one that looks like that. And so my choices were 1.48571 with the line over this. That's not true because the decimal point's in the wrong place. They do have this answer, they have it without that, and then they have it as the wrong answer with the 1 decimal point. Let me change the button on my calculator. My calculator is not set up really well. Yeah, okay, now I'm better. So I wasn't able to see out beyond a certain decimal point, which would be a problem in this one, so I had to change it to floating. So if we go and look at maybe another one like this, no, actually there's just one that's like that. Oh, we have this one. 13 over 33. Now, what are we expecting? With a 3 involved, we're expecting it to go on forever. Let's look at what 13 divided by 33 is. Here's what's coming out on a calculator. 0.39393993, and it just keeps going. And so what's the right answer? 0.39 with the line over it. That's what you'd be looking for. Right? Because these are all 0 points. They're all less than 1. So they just want you to get an idea of repeating decimals. Now, the end part is where we're at now. We're at the last like 5 or 6 problems. And they want to just make sure we can translate from decimals to fractions. And it's very easy to translate from decimals to fractions, especially if you know how to read them. So let me write out a decimal. 1.2345678 I'll just stop there. Sorry, I didn't need to go beyond there. So there's a decimal, and what we want you to realize is the place names. This is the ones. This is the tenths. Hundreds. Thousands. 10,000s. And I doubt you'll have anything beyond there. Okay, so knowing the place names is really important. So I wrote up a problem. They want to write 0.6 is equal to what as a fraction? And that's a really easy problem to solve if you know how to read it. This is the number 6. We read the only number present and then name its placement. 6/10. 6/10. Now they won't leave it like that. They'll reduce it. But 3/5 is that answer. If you looked at 3 divided by 5, it would come out to be 0.6. And so they're just wanting to remind you how to translate between there. I'm seeing one here, 0.854. Well, how do we read that? We read it as the number before the decimal, which is nothing. So we read the number after the decimal, 854, and then, 854, and then say the place name of the last digit, which is the thousands. Tenths, hundreds. So this is the tenths, this is the hundreds, and this is the thousands. There's no ones. So that's the thousand. So it's just 854 over 1,000. So we got to reduce that because both are at least are divisible by 2. So let me take 854 and divide it by 2, and we get 427 all over 500. Now 500 is just made up of 5s and 2s, neither of which go into 427, so we're finished. So we're good there. So we can see that we're using our least common multiples, greatest common factors throughout this one. Here's an interesting one. And they have a model as the last exercise that they show, last example that they show in the 6.3 book. 0.56 repeating. So remember what this is. This is 0.565656, and they want us to accomplish the same thing. Write it as a decimal. Well, there's a trick. The trick is to multiply by 10 raised to the number of repeating numbers. Okay, so in this case, 56, or a 5 and a 6 is repeating, so we're going to multiply by 10 to the second power, which is 100. So we're going to look at 100 times 0.56 repeating. Well, what will that be? If you multiply by 100, it just moves the decimal point twice, and we get 56.565656. Okay. So now, what are we going to do? We're going to take, and I'm going to try to follow the method that they do. So they're going to, here's what they do, and so let me follow it exactly, and then come back to this. So their step 1, when it's repeating like that, is to let x be the repeating number. So in this case, 0.565656. Then step 2 is to write 10 to the second power times x, because that was the number of repeating decimals, which is 56.5656. And you'll see why we're doing this in just a minute. So now we're going to put on our algebra hat. So I have 100x, which was 56.565656, and it keeps going, right? I should put dots after each one of these, minus x, which is 0.565656, and look what you get. You get 99x is equal to 56, because this part right here, if we're subtracting, is all the same, so it's going to 0, and we just get 56. So what's the answer? 56 over 99. Now we got to ask ourselves, does that reduce? And I don't think it does. 99 has an 11 in it, which 56 definitely doesn't have. It has a 3 in it, which 56 doesn't have because it adds to be 11. 56 over 99. Occasionally they will reduce, but that's our guy, right? And so that's the trick. So there's a few of these at the very end that I have you practice with. Check out something like this, 0.045, and the 45 repeating. Here we got to get a little bit creative. So remember the goal. So we're going to let x be 0.0454545 4, 5. And our goal was to get rid of it. So if I look at 1000x, what that will do is move my decimal point 3 times. Now I think I need to move it 3 times in order to get a 4, 5, 4, 5. Sorry. In order to get my 4, 5 repeating. So why did I go out 3 that time? Because it actually contradicts what I said. You want to move it until you're able to clear that repeating number. So I needed to move it 3 times, so I multiplied by 1000, which has 3 zeros. Now if I were to subtract these right now, I'd have a problem. If I were to take 1000x, which is 45.454545, and subtract away x, which is 0.045, everything's misaligned. It's not good. But what if I did 10x? What if I just did 10x? You're going to have to be creative here. If you do 10x, it moves it once, and you get 0.454545, and now they line up. So 1000x minus 10x is 990x, and that's going to subtract to 45. And you're going to divide both sides by 990. And so look what you have. You have x is equal to 45 divided by 990. Now both of those are divisible by 9, because we know 9 times 5 is 45, and 99 divided by 9 is 11. So we get 5 over 110, but even that's reducible to 1 over 22, right? 1 over 22 would be the answer that they have in the back. So we're going to have to get a little bit creative. So your goal is to get this situation here, right? And so good thinking in there, trying to get that to be the way that it is. Let's try that one more time. I'm seeing another one, 3.03. So all of these I'm finding in the homework, so it should match. 3.03. Well, with the 3 repeating, so let's let x equal 3.03333, and it goes on forever. So remember our goal. Our goal is to get rid of those 0.333s, to line them up. How do we do that? Well, let's look. If we look at 10x, that's 30.3333. And if we looked at something like 100x, what's that? That is 303.3333. We could work with that. Why can we work with that? Because our decimal, as you look at the decimal point and to the right, they'll all go away. So I don't know if this is the most efficient way, but it will work. If we take 100x and subtract away 10x, what we're doing is taking 100x, 303.333 repeating, and subtracting away 30.333 repeating. So what do we get out of this? Well, out of this side we get 90x. And out of this side, what do we get? If we take 3 minus 0 is 3, 30 minus 3 is 27. So we get 273 over 90. So we're going to divide by 90. And x is going to be 273 over 90. Now we need to check to see if we can reduce. The top is divisible by 3. 7 plus 3 is 10, plus 2 is 12. So if we take the 273, and we're going to use your calculator, and divide it by 3, we get 91. And on the bottom we would get 90 divided by 3, which is 30. Well, there's nothing more you can do to reduce that. 91's prime, and 30 has nothing in common with that number, so there's our guy. So that's the way this homework is, and these are the last questions, the ones that are having you deal with this, but it's really good mathematical thinking and manipulation in that. So have fun with it, and come to Zooms if you're having questions. Not many people are, so take advantage of that. And then also feel free to email me questions that you might